So, what is a microcontroller? What are the advantages of microcontroller? Just now we saw. Then applications of microcontroller. Then the most important thing is features of 8051. What are the different microcontrollers? 8048, 8049, 8050, 8051. Then you have 8052. Then you have uh, basically other microcontrollers like 8732, 8734. Then you have 8759. Okay, all those are your microcontroller. Different families of microcontrollers you should know. So out of that 8051 say features they are asked. So basically there are 11 features. Out of that you have to do minimum 8 features, because if it is for 4 marks you have to basically do it write 8 points, but do all the 11 features because they can ask you in the fill in the blanks. So 8051 microcontroller has 8-bit ALU, that is arithmetic and logical unit. Then it has 4 kilobyte of internal ROM or EPROM. Then it has 128 byte of RAM, internal RAM. Then it has dual 16-bit timer event counter. Then it has basically 32 IO lines, that is input output lines. Then 111 instructions. It can address up to 64 kilobyte of program memory. It can address up to 64 kilobyte of data memory. It has 2 external interrupt, 12 megahertz clock frequency, fully featured serial port. So these are the basic or main features of 8051. Okay, so basically they can ask you in the fill in the blanks or in the questions also, write the features of 8051. Okay, then internal block diagram of 8051, you need not have to do it. Only thing is architecture wise, if you want to see, you should write there is a 8-bit ALU in it, right? Then it has 32 input output lines. That means 4 8 bits input output, 4 4 ports ahead, 8 bits, right? So total 32 input output lines are there. Then basically there are clock frequency 12 megahertz साठी the pins are there. Okay, crystal साठी. Then power supply साठी pins and timing and control signal साठी pins are. Then it has basically 32 general purpose registers. It has a block of registers, general purpose registers, accumulator ahe, stack pointer ahe. So those are the things you can write about the architecture. They never ask you about that architecture, but in case if they ask you, you have to write these things. It has internally 4 kilobyte of ROM and 128 byte of RAM that you have to write. Then this is asked, this question is asked many times, memory mapping of 8051. So basically explain the memory mapping or how the two separate memory spaces are addressed by the 8051. So basically there are two spaces, memory spaces. One is called as the program memory and the second one is called as the data memory. So program memory, as we saw in these particular features, it can address up to 64 kilobyte of program memory and it can address up to 64 kilobyte of data memory. So the program memory addresses will be from 0000 to FFFF, right? So that 64 kilobyte of ROM or EPROM it can address. Now out of that 4 kilobyte of internal ROM 8051 has. So the addresses of that internal ROM will be from 0000 to 0FFFF. Then the next address is 1000 to FFFF. So 64 madle 4 gele, so 60 remains. So up to 60 kilobyte of ROM or EPROM it can address. So total 64 kilobyte of ROM or EPROM it has. Then the data memory is again a 64 kilobyte of RAM you have. So 0000 to FFFF are the addresses. Out of that, internal RAM memory kiti hai? It is 128 bytes of RAM. So 128 bytes of RAM, therefore the addresses will be from 000 to 007F. And it has special function registers, 22 special function registers are there. So 7F nantarचा address आहे 80 to F8. Okay, so the registers is also considered as the internal memory, but it is different than 128 byte of internal memory, right? So that you have to just remember. So basically this particular memory map, they can ask you to draw, well as they can ask you to explain the memory mapping. So basically whenever you are drawing, the addresses are very important. Okay. So these addresses you should remember. So हे जे features आहेत त्यातले कुठले कुठले आपण वापरले memory mapping साठी 64 kilobyte of program memory, 64 kilobyte of data memory, 4 kilobyte of ROM and 128 byte of RAM. Those features we used to draw this particular memory mapping of 8051. Then if you want to explain it, program memory is a read-only memory. So basically you cannot write into that memory. So the instructions or the programs are usually stored in that memory. The instructions are fetched from that particular memory. Then it has 4 kilobyte of ROM, internal ROM, right? So it has the addresses from 0000 to 0FFF, and additional 60 kilobyte of ROM or EPROM can be attached, okay, which has the addresses from 1000 to FFFF. Data memory is a read-write memory where the contents can be written or read from, right? So basically it has the total address of 000 to FFFF. Out of that, 128 byte of RAM is internal RAM. So 0000 to 007F. That is the address which is for your 128 byte of internal RAM, which is used for general read-write data storage. Then it has 22 special function registers. So they hold the address from H0 to F8H, and from F9H to FFFF, we can use the external RAM or external RAM. Okay, so that is what you can write about the data memory. Then the question can be asked to compare the different families, right? Especially 8051 आणि 52 याच्यातले जर difference विचारला, then basically there are three main points. One is your ROM area, RAM area, and जो counter आहे, okay, dual timer counter, that. So these will be expanded in 8052. That is 8051 has 4 kilobyte of internal memory. 8052 will have 8 kilobyte. 8051 has 128 byte of RAM. Here it has 256 bytes of RAM. Here it has only one event timer counter. It has two timer event counters. Okay. So these are the three main different points or points of differences between 8051 and 8052. Extra points if you want to write, you can write about the cost. Cost is more for 8052 than 8051. And 8052 AH basic, this particular microcontroller can be used to write a program in basic language. You can write a program in basic language with that. Then 80484950, usually the memory capacity reduces. Okay. So basically memory capacity, suppose 8048 has 1 kilobyte of ROM, 8049 has 2 kilobyte of ROM, and 8050 has 4 kilobyte of ROM, internal ROM. 8048 has 64 bytes of RAM, 49 and 50 has 128 byte of RAM. Okay, so that is the thing which you can write. Then these microcontrollers are low cost products and they are very popular. Low cost products मध्ये वापरतात, therefore cost wise it is very effective. Then 8031, 8032, if you see, right? See, these do not have the onboard ROM, internal ROM they don't have. So externally you can use the ROM for the program memory. Okay. So basically low volume products study, they are useful. Then if you see 8751, 8752, they do not have the, sorry, they have the onboard EEPROM. Instead of ROM, they have the onboard EEPROM with them. Okay. So these are the points of differences which you can write. Then the basic difference, they can ask you about 8051 and 8085. Or they can ask you the difference between microcontroller and microprocessor. So if they ask you the difference between the microcontroller and microprocessor, so basically general microprocessor they are talking about and general microcomputer they are talking about. So microcontroller is a chip which is a single chip computer, and here you need the, basically it is a nothing but a CPU. Microprocessor is nothing but a CPU. Microcontroller includes RAM, ROM, IO ports, okay, on a single IC. Microprocessor does not contain the IO ports or the RAM, internal RAM or ROM. Then basically microcontroller based systems are cost effective, where these are very expensive. Microcontroller do not need the peripheral devices. Here you need the peripheral devices. Okay. So those are the points of differences. But if they ask you about 8085 and 8051, then 8085 is 8-bit microprocessor, 8051 is 8-bit microcontroller. Okay. Then basically it has 16-bit addresses, therefore it can access 64 kilobyte of memory, where it doesn't have the addresses, right? It has actually the ports. Okay, IO ports are there. 8085 मध्ये तुम्हाला IO ports लागत नाही, right? So there are basically no 8085 मध्ये you will need the peripheral chips. 8051 मध्ये you don't need any peripheral chips. Then if you see there are 7 general purpose registers in 8085. There are 22 special function registers plus some extra registers are there. So total 34 registers are there. Here 8-bit flag register with 5 flags. Here 8-bit flag register with 6 flags are there. Okay, so these are the points of differences in 8085 and 8051 microcontroller. Okay, so very easy chapter. Just do the question answers which are given below the chapter, nothing else. Okay, no extra things you have to do in this chapter. Any doubt in this? Okay. Six family, again 4 marks चा question असतात, but last year थोडासा जास्त मार्कांचा विचारलेला x86 बद्दल. So basically you have to just do this particular table properly. See, there are 3 main questions which are asked in x86. One is the comparison of different families or writing the features of different families. Then they can ask about the programming model of 16-bit or 32-bit microprocessors and advanced features of Pentium. These are the main questions which were asked. Okay. So this particular table is very important in order to write the features or compare the things. Now, x86 मध्ये you have 16-bit microprocessors, 32-bit and 64-bit microprocessors. So when you talk about it is a 16-bit microprocessor, it means it can process those many bits data, right? So 8086 16-bit आहे, that means data bus 16-bit, 80286 16-bit, 32-bit, 32-bit and 64 bits, right? Address bus is 20 bits. Here it is 24 bits. Rest of the 3 processors, 32-bit. So 2 raised to 20, that is 1 MB memory it can access. 2 raised to 24, that is 16 MB memory, and 2 raised to 32, yani 4 GB memory they can access. Operating speed, it increases. For Pentium, it is up to 100 megahertz. Okay. Then internal memory management is there for 486 and Pentium. Rest of them have the external memory management, as well as they have the external maths coprocessor. While 80486 and Pentium has internal maths coprocessor, so that the mathematical functions are done fast. Okay, so usually they can ask you about the 8085, 8086 features, or they can ask you about the architecture of 8086 or 8088. Same आहे. 8086, 8088, 80186, 80286, similar आहेत. Okay. So basically advantages of these higher versions are you have the increase in the memory capacity, increase in the execution speed, powerful instruction set is there, therefore multiprocessing environment is possible, and programming in higher language is possible with these 16-bit or 32-bit microprocessors. So basically, if you see the 8086 or 8088 architecture, if you want to see, there are two units. One is your execution unit, and the second one is your bus interface unit. The bus interface unit is going to fetch the instruction and put it in the instruction queue. Therefore, bus interface unit part contains of the instruction queue, segment registers, and the instruction pointer, and you have the bus address generation and bus control. In the execution unit, it is going to read the instruction from the instruction queue till the instruction queue becomes empty. Therefore, you need the flag register, general purpose registers, then you have the ALU, and the whatever is the operational registers you need, those will be there. Okay. So what is a bus interface unit? Bus interface unit basically sends the address. It fetches the instruction from the memory, reads the data from the memory, and then basically just once. So basically what is there is it sends the addresses and fetches the instruction from the memory. Okay, so basically if you see bus interface unit will send the addresses, it will fetch the instructions from the memory, it will read the data, okay, from the memory or whatever are the input output ports, okay, and then basically bus interface unit will handle the transfer of the data and the addresses, right? Then this is the instruction queue where the maximum six instructions can be stored in this particular instruction queue. The segment registers are there. For example, extra segment, code segment, stack segment, data segment. So each segment is used to store the, for example, data segment is used to store the data, stack segment, register contents, code segment, instructions. So it has 16-bit starting address of the segment. Then instruction pointer is a program counter. So it will hold the address of the next executable instruction. The execution unit consists of flag register, right? So it has flags, okay? So 16-bit flags as that. So out of that, there are 9 flags. Then you have the general purpose registers, AX, BX, CX, and DX, okay? So basically, they are used for the temporary storage of the data. And then you have the stack pointer also in this, which will point to the top of the stack. So that is nothing but your architecture of 8086. Now 8086 is a main feature set. It is a 16-bit microprocessor, right? It is a 40-pin DIP package. It has. So 20 bits address hai, so 1 MB memory hai, and 10 megahertz up to frequency. So these are the points which are given in the table also. Now this microprocessor operates in two modes, minimum and maximum. In the minimum mode, actual microprocessor works. Maximum mode, the coprocessor, math coprocessor will work. Multiprocessing environment hai, and out of this 20 bits address, 16-bit addresses are multiplied with the 16-bit data, and remaining 4-bit are multiplexed with the timing signal. Okay, so that is nothing but your 8086 features आहे. Okay, so programming model जर तुम्ही बघितलं, so I was talking about AX, BX, that is nothing but given in the programming model. So AH, AL, BH, BL, CH, CL, DH, DL, all these are your general purpose register. Individually, they are 8-bit, okay, but together they can have the 16-bit, right? So 16-bit, AX is nothing but your 16-bit, BX is nothing but your 16-bit, CX is nothing but 16-bit, and DX is nothing but 16-bit. So AL, BL, all these are lower byte wale registers, and AH, BH, CH, and DH are your higher byte wale. Then you have the source index and destination index. These are the index registers. Then you have the base pointer and stack pointer. These are the pointers, which are again 16-bit registers, which will point to the, these are the pointer registers because they will point to the locations within the segment. Then you have code segment, stack segment, data segment, and extra segment, again 16-bit segment registers. Basically, code segment will consist of code. Stack segment will consist of the, for example, register pair contains. Okay. Then U is nothing but, okay. Okay. Just once. So these are nothing but your, and flag register is nothing but your 16-bit register. Okay. So 32-bit microprocessor programming model. Similar programming model, the only thing is now you have the extended AX, extended BX side. Okay. So that is the only thing which is different. So up to the pointers, you have the 32-bit microprocessor. Okay. So that is nothing but you have to. So in this case, if you see AHAL, okay, these will be making 16-bit register, and EAX is another 16-bit. So total, you have the 32-bit general purpose register A, B, C, and D, right? So these are your general purpose registers. Then you have the extended SI, that is source index and destination index, again 32-bit index registers which you have, right? So basically they are used in the string operations. Then you have the pointers, base pointers, and stack pointers, right? So these are again your 32-bit registers which will point to the basically the base address किंवा त्याला usually they point करतात. And then you have the segment registers, code segment, stack segment. Okay, all these are 16-bit registers. Code segment, stack segment, data segment, extra segment, F segment, and G segment. These are 16-bit registers. Okay, so basically they will be used to store the codes, data, some subroutines, and they will deal with the external memory. Then you have the instruction pointer, so which is also point to the next executable instruction. And then you have the flag register, which is a 32-bit register, okay, which will give the status of the answer. So these are the programming models which they can ask you. So both the programming models are easy. Okay, एकाच लक्षात ठेवलं की ऑटोमॅटिकली तुम्हाला दुसऱ्यांचं कळेल. Then you have the basically comparison between 8085 and 8086. So 8085 is 8-bit microprocessor. This is your 16-bit microprocessor. So 8085 can process 8-bit data at a time, where 8086 can process 16-bit data. 8085 has 16-bit address, so 2 raised to 16 combination, that is 64 kilobyte of memory is possible. 8086 मध्ये 20-bit address आहे, so 2 raised to 20, that is 1 MB memory. Then clock frequency for 8085 is up to 5 megahertz. Here it is 6 to 10 megahertz. In 8085, lower 8-bit of address are multiplexed with the 8-bit data. In 8086, 16-bit addresses are multiplexed with the 16-bit data. 8085 operates in only one mode, but 8086 operates in 2 modes, minimum and maximum. Then every features which are the 8028, again 16-bit microprocessor, 24-bit address, so 2 raised to 24 means 16 MB memory, clock frequency up to 20 megahertz. हे पॉइंट तर तुम्ही आरामात लिहू शकता. त्याच्यानंतर instead of 40 pin, now it is a 68 pin DIP package IC. Then basically, in this case, if you see, it supports the memory management unit. Okay, because of memory management unit, it supports up to 1 GB OD memory. Okay, then basically, if you see, it restricts. Basically, it has a mechanism to protect the system software. Okay. 8086 can run on 80286. Okay, so real addressing mode वगैरे हे प्रकार त्याच्यात असतात. त्याच्यानंतर बेसिकली व्हर्च्युअल मेमरी 1 GB एवढी असते त्याच्यात. ओके, अँड मल्टी युजर सिस्टीम आहे. 80386 32-bit 32-bit address, so 4 GB memory, 132 pin grid array package आहे. Then 33 megahertz एवढा clock frequency आहे. Then basically multi-user and multitasking system आहे. Okay. So basically memory management mode मध्ये paging येतं आणि नॉन पेजिंग सुद्धा असतं याच्यात. Then basically virtual addresses असतात त्याच्यात. So all those features you can write if you want, otherwise these are the points which are also enough. Then 486, 80486, again 32-bit address, so 4 GB OD memory, 168 pins IC आहे. Okay, and 66 megahertz पर्यंत clock frequency. So now it has a built-in maths coprocessor, so the mathematical functions can be processed faster. 8 kilobyte of data and code cache memory आहे. Highly pipeline execution unit आहे. High-end computers, okay, can execute high-level languages. Multi-user, multi-processing system. Pentium, right? Pentium 64-bit microprocessor आहे. 32-bit address, okay, so 4 GB OD memory access करू शकतात. Then 64-bit data bus आहे. So execution or transfer of data will be much faster असणार आहे. Okay, up to 100 to 233. आता new versions will have more faster clock frequency. त्याच्यानंतर high-end PC मध्ये they are used basically. Then multi-processing system मध्ये different operating system like Unix, we can operate on it. Okay, so all these are the main features of Pentium. Then usually they ask you about the advanced features of Pentium. Okay, So in case of advanced features of Pentium, what you have to write, they will ask you only mainly four points. One is dual pipelining, on-chip cache, branch prediction, and 64-bit database. So what is dual pipelining? Basically, when it can execute more than one instruction per one clock cycle. Okay. So that is why the performance is of high level. Okay. More than one instruction can be executed simultaneously. So that is also called as the dual pipelining. On-chip cache memory, if you see, basically in order to improve the processing speed, okay, because see, when the memory has a slower memory are slower than your CPU, right? So CPU speed is faster than your main memory speed. So the instructions which are required often or the data which are required often are stored in the memory which is faster, okay, which is faster than this particular slower memory, which is called as the cache memory. Okay. So in this case, what happens is the instructions which are required again and again will be uh, taken from this faster memory, eliminates the need of the processor to go off the chip and access the main memory during, especially in the loop instructions. Branch prediction. In this case, basically, what is the next instruction? It usually guesses. Okay. So that is called as the branch prediction. So what it does, it prevents the instruction cache from running dry in the conditional instruction. And then it has a 64-bit data bus. So 64-bit data bus, because of that, the high-speed data transfer is possible. Okay. Other two are never asked, performance monitoring and high performance floating point. But you can always write performance monitoring means it can monitor its own performance, and high performance floating point unit, because of that mathematical calculations will be much faster. Okay, because floating point unit I which can executed more than one, so dual pipelining type structure असतं त्याच्यात सुद्धा. Okay, so that is the thing, but these two are never asked. Usually first four are asked. Then they can ask you to compare 80386 with Pentium, किंवा 80486 with Pentium. Any two they can ask you to compare. Okay. So for example, 80386 and Pentium तर काय लिहिणार, 32-bit, this is 64-bit. So 32-bit data, 64-bit data, right? Then basically आता address तर त्यांचे same आहे. So this cannot be your comparison point. When it was introduced, that you can write here 85 मध्ये, and this is in 93. Clock speed is different, right? 50 megahertz पर्यंत आहे. Sorry, 80386 33 megahertz पर्यंत आहे. Pentium 100 megahertz पर्यंत आहे. Then basically external coprocessor आहे, external memory आहे, and it has internal coprocessor and internal memory management आहे. Okay. Then basically जर तुम्ही बघितलं तर 16 bytes cache memory आहे 80386 ला. इथे 8 kilobyte of cache memory that you can write. Okay. 80486 Pentium, again same 32-bit, 64-bit. Then 50 megahertz frequency, 100 megahertz frequency. 91 मध्ये आहे, हा 93 मध्ये आहे. It has 32 bytes memory, 4 and it has 8 kilobyte of cache memory आहे. Okay, instruction cache म्हणतात त्याला. So that is the thing which you can write. So these are the things which you can always comparison मध्ये ह्यातले जेवढे comparison points आहेत that you can take it. Okay, so this chapter is also for 4 marks. So question answers which are given below the lesson that you can do. Is usually asked for 17 to 20 marks, कधी कधी 23 marks पर्यंत सुद्धा नेटवर्किंग चॅप्टर वर येतं, and very easy chapter. Okay. In the networking chapter, there will be one question on the topology always, and connectivity devices वर एकतरी question हा असतोच असतो. So you have to do those basically topics properly. Okay. So basically they can ask you what is the networking and what are the advantages or types of networking मध्ये they can ask you to compare, right? So networking मध्ये basically networking मध्ये the different computers are interconnected to each other so that they can uh, uh, share the resources as well as the information. Okay, then it is nothing but called as the networking. So basic advantage of the networking is it is cost effective. Then basically they are more reliable. Even if one computer fails, still another computer is working. So it is more reliable. Information exchange is much easier. You don't have to actually take the physically, you don't have to transfer it. Okay, automatically it will be transferred from one place to another. So three types of networking is nothing but LAN, then you have MAN, and then you have WAN, right? So three types of networking are LAN, MAN, WAN. So local area network, metropolitan area network, and wide area network. These are the three types of networks. So according to the area, the LAN has the smallest area, right? For example, computer lab. MAN in the city cable network can be considered as your MAN, or it can be the paging system. WAN is nothing but the mobile system or the full internet facility of the network. So area wise, they are bigger. Then transmission media which they use is nothing but in LAN you use wires only. MAN मध्ये सुद्धा wires वापरतात. WAN मध्ये you can use the wireless media. Then speed of the system will be much higher in LAN than MAN than WAN. Okay. Then electromagnetic interference in the wireless media, it is more as compared to this. Attenuation is less. Okay. So these are the points of differences which you can write in the LAN, MAN, and WAN. Then physically, how you connect the computers together. Okay, that is called as the topology. And there are three types of topology: star topology, bus topology, and then you have the ring topology. So out of that, that ring topology is the cheapest one. Okay, so whenever you are going to explain them, you have to draw the diagram compulsory. You have to write how the communication is done. Okay, and then advantages and disadvantages of each. Okay, so in the ring topology, the nodes are connected in the form of the ring, or the communication is in the form of the ring. The computer A will send the information to computer B, then to C, then to D, right? So direct communication is not possible with the ring topology. Okay, everyone gets a chance to transmit the data in case of ring topology. That is the advantage. Okay, disadvantage is communication is not direct. So basically you cannot, I mean, it is a time consuming process. Then if you see, adding a node and removing a node is difficult in case of ring, because you'll have to disconnect all this particular connection and then make a new connection. Cheaper, ring topology is cheaper and every node gets the, again the disadvantage is one computer fails, the whole system will fail. In the star topology, you have the central device called as controller or the hub, and the computers are connected to the central devices. The communication is two-way. A computer, if it wants to communicate with the B computer, okay, then basically it will communicate to the through the central device. So again, the direct communication is not possible here. So again, it is a time consuming. If the central computer fails, naturally the whole system fails. But if one computer fails, the system will not fail. Okay. Then it is easier to add any node or remove any node in the star topology, because the central controllers or device say that is hub मध्ये, it is easier to add the content nodes, computers. Okay. Then bus, there is a bus, okay, connecting all the computers, right? So there is a direct connection between the computers. If a computer wants to communicate with B computer, it can directly communicate. Okay. And then suppose if you see here, in this case, there can be a collision of the data if the computers are sending the data. Okay. And it will have, if any computer wants to transmit a data, it will have to wait till the path is free. Okay. So that is the disadvantage. But the bus topology is the most reliable topology. Even if one computer fails, still your computer or system will work. The network system will work. Okay. That is the main advantage of the bus topology. So these are the three topologies which you have to, and this particular topic you will have to do it properly, because either they will ask you to compare the three topologies, or they can ask you to explain the topologies. Okay. So this particular topic you do it properly. Then the transmission media characteristics, the transmission media which you use, the 6 characteristics are cost. Okay. So cost depending upon the cost of media. That means depending upon whether the media is costly, the whole system will be costlier. Okay, so the UTP STP cable are cheapest one as compared to your coaxial and fiber optic cable. Then installation requirement, if you see, in this case, installation cost, you need a skilled labor. Okay, so that is the problem. So if you need a skilled labor, the installation cost will be more. Or for installation, you need extra. So there the installation cost will be more. So for example, fiber optics has more installation cost. Then bandwidth. Bandwidth is nothing but the amount of frequency which can be sent without having any distortion, that is called as the bandwidth, or it is a measure of capacity of the medium to transmit the data. So in digital media, the data transmission rate is in bits per seconds. Okay, bandwidth is measured in bits per seconds. So for example, the short cable जर असेल तर greater bandwidth असते, long cable ला ती bandwidth will be more less bandwidth असणार आहे. Okay, so basically the proper shielding वाले wires लागतात to have the larger bandwidth. So basically fiber optics has the highest bandwidth and UTP STP cable has the lowest bandwidth. Then band usage. There are two types of band usage. One is called as the base band and second one is called as the broadband. Okay. So band usage madhe, basically if it is a base band, in this case the whole band of frequency is nothing but sent as a one I mean the different frequencies are sent as a one band. Okay. So basically, baseband devotes the entire capacity of the medium to one communication channel. While broadband madhe, there are two or more communication channels. That means you can say modulation wise, they are sending the frequencies. Okay, so it will be the channels of the frequencies, different channels of the frequencies in the broadband. Then attenuation. Attenuation is nothing but the amount of signal which gets weakened after a certain distance. That is called as the attenuation. If your width is strong, then I mean attenuation madhe, suppose your shielding is strong, then the attenuation will be less because there will be less loss of the signal, right? So larger the distance, the attenuation will be more. So basically fiber optics मध्ये there is the attenuation is less, and UTP STP cable मध्ये basically the attenuation is more. Then immunity from the electromagnetic interference, right? Whenever an electrical signal is sent, naturally there will be a magnetic field which will be generated, and then electromagnetic interference is nothing but the interfering signals in the actual signal, and basically then it will be difficult to decode the signals, right? So strong shielding is also required for this electromagnetic interference. So these are the six basically uh, uh, transmission media characteristics. Then you have the bounded and unbounded media. Okay, so in case of bounded media, you have the cables. One is your UTP cable, that is unshielded twisted pair cable, shielded twisted pair cable, coaxial cable, and then you have the fiber optic cable, right? So these are the four cables or bounded media which you have to learn. So UTP STP cable, these are the twisted pair cables, right? So basically the pairs are twisted, and in unshielded twisted pair wire there is no shielding which is there, but in the shielded twisted pair wire there will be a shielding. So you'll have to draw the diagram if they ask you to write a note on the UTP or STP. But if they ask you to compare, no need of drawing the diagram. Okay. So basically shielded pair, here again you'll have to talk about, whenever you're comparing, you'll have to talk about the cost. You'll have to talk about the installation cost. Then you have to talk about the bandwidth, and if possible band usage, then electromagnetic interference and attenuation. These are the points which you want to. So naturally UTP has less cost, right? Less installation cost, less bandwidth, more EMI, and more attenuation. STP cost is more than UTP, less than coaxial, right? Installation cost is less than coaxial, more than UTP, and bandwidth is more than UTP but less than coaxial cable. Electromagnetic interference is less than UTP, more than coaxial cable, and so on. Okay, so that you have to write. Then coaxial cable, basically these are nothing but the cables which you see in the usual PVC cable made. So here you have the center conductor. Okay, it is a solid copper wire, and then outer conductor you have, okay, which is nothing but an you have the insulator over that copper conductor, and then you have the outer shielding, and then you have the uh, uh, plastic jacket. Okay, so just see that particular diagram, draw the diagram. There are two types of coaxial cables. One is a thick and second one is thin. So thin is flexible and inexpensive, thick is hard and expensive. Okay. So basically advantage and disadvantage comparing with UTP, STP and fiber optics, you can always write. Again, the points of differences will be these. Then fiber optic cables is basically, it carries the light instead of electrical signal. Okay. So basically light wave can be directly conducted through the transparent glass fiber cables known as fiber optic cables. So center conductor is a cable which is a fiber that consists of highly refined glass or plastic. Then it is designed to transmit the light signals with little loss. Then on that fiber, there is a cladding, okay, or it is a gel which reflects the signals back. And then on that, you have the plastic jacket, okay. So that is the diagram which you'll have to draw. Naturally, cost will be more, installation cost will be more, bandwidth will be more, EMI will be less, attenuation will be less. Fastest कम्युनिकेशन असणार आहे फायबर ऑप्टिक्स मध्ये, बिकॉज द लाईट वेव्स आर ट्रान्सफर्ड, दे आर फ्लेक्झिबल असतात, देन लाईट वेट असतात, नो काय म्हणतात टेम्परेचर और केमिकलचं काही रिॲक्शन होत नाही त्याच्यावर. ओके, सो दॅट इज नथिंग बट युअर advantages or disadvantage of the fiber optic cables. Then unbounded media मध्ये advantages of unbounded media or disadvantages of unbounded media, they can ask you over the bounded media. So basically larger distance can be covered, right? Hilly region or any rural area मध्ये wireless media can reach at the faster speed actually. Then basically there are no wires required. So basically no tangling of wires is there with the wireless media. Okay. So those are the points which you can write. They can cover large area. Okay. Basically the packet radio, microwaves, and then you have the satellite communication, which is never asked actually, but you can just go through them, right? Satellite communication, so you know, from the earth, the transmitter will transmit the data from in one, which is called as the uplink frequency, and it is received by the satellite, and then the signal will be transmitted from the satellite at the receiving end with the downlink frequency, right? So here you have the tower, right? Receiving end, here you have the satellite. So this is your uplink frequency. So two-way duplex communication असतं याच्यात. Okay, so that is nothing but your satellite communication. Advantages, disadvantages can be used for many purposes like armies आहे. Okay, then you have the okay weather forecasting, किंवा in order to see any place, you can use the satellite communication. So all those things you can write, but they are most costliest technology ahead. Microwaves, basically, if you see in this case, the microwaves are the southern 100 gigahertz frequencies waves असतात. So they can bend through or go through any obstacles, right? So basically, if you see, these are used for long distance communication, but there you need again and again, you will need the periodic repeaters. Okay, then radio waves. Sorry, packet radio. Packet radio is something like a walkie-talkie. You have a transmitter, okay, which will send one frequency and receiver end. So for the small distance, you can use this. So computer digital signal is given through the transmitter, and the receiving end, it will receive another frequency, and then it will send it to the computer. So these are the things they have never asked about it. Okay. So don't, I mean, you can just go through that particular topic. Then I think you have the connectivity devices. So for connectivity devices, this particular topic, you should do it thoroughly because they will ask at least one question on that. So explain all the four connectivity devices, or they can ask you to explain only one connectivity devices and so on. Okay, so basically the four connectivity devices are hub, then modem, repeater, and router. Okay, so what is a hub? Hub is a connectivity devices which can basically, in which the cables can be connected to the different computers, right? Through the different computers are connected through the cables. Okay, no need of using the soldering. Okay, so you have a single connecting point where you can connect the different computers with the help of the cables in the sockets. Okay, these are the types of sockets which are used. Now the hub is nothing but can be used as a central device in the star topology. Okay, So there are three types of hub: passive hub, active hub, and intelligent hub. The passive hub will just send the signal, okay? Then active hub will actually amplify the signal. So passive hub doesn't have the electronic component. Active hub can have the electronic component, which can basically amplify the signal, okay? And apart from retransmitting it, and intelligent hub can actually divert the path also. That is, it has certain software can be developed, okay, by the intelligent hub to choose the path, okay. So that is the nothing but three types of hub. So always remember, uses you have to write, okay, construction or diagram you can show, and then the types you must write. Then modem is nothing but modulator, demodulator. Whenever you want to send the digital signal to the other devices through the telephone lines, okay. So digital signal has to be converted into analog and analog to the digital, okay. Then it is nothing but the modem is used. So at the transmitting end, the digital signal is converted into analog by the modem, okay, and then it is given through the telephone lines, okay. At the receiving end, the analog signal is demodulated by the modem, okay. So analog signal is converted into the digital signal in this case by the modem here, right? So receiving end la modem will convert analog signal into digital, and transmitting end la digital into analog, right? So that is nothing but the use, that is how the communication takes place with the help of the modem. So earlier the fax machines were using the modems, then internet, email, chatting साठी we can use the modem. There are two types of modem, asynchronous modem and synchronous modem. So asynchronous modem मध्ये basically transmission clock is not used, or not synchronization is checked, okay. In the synchronous modem uses the clock for transmitting and receiving the devices. They use the sync signal, okay. So these are the types. Then you have the repeaters. Repeaters will just, whenever there is an attenuation, repeater will repeat the signals. So repeaters are mainly used to repeat the signal when the signal gets weakened. Okay. So there are two types of repeater. One is just signal will just resend it, and the second one is nothing but it will amplify or weaken. Okay. Then the third. Then the routers are basically used to connect the smaller network to the higher network, larger network, or larger to the smaller. Okay. So there are two types of routers. One is called as the static router or dynamic router. So whenever you want to connect LAN to WAN, WAN to LAN, you can use these routers. So basically what you can do is the static routers will not determine the path. They will use the path which they have specified. Dynamic routers, basically they can determine the path. Okay, so that is nothing but the router. Except routers, all the diagrams are available in the notebook or in the book. Okay, so routers usually they एवढं हे नाही करत, कुठला डायग्राम चालतो. Then protocol किंवा architecture. Okay, so protocol is nothing but set of rules, or the basically protocol is defined as the agreement between the communication, right? Agreement for the communication way, right? So basically these are the rules set by which the computers can communicate with each other when they are connected in the network. There are usually TCP/IP protocol बद्दल विचारतात. So transmission control protocol or internet protocol basically is used. They do not belong to any one company or technology. Okay, there are three, two, two types of address, three types of addresses. One is your hardware address or physical address, which is used by the data link or physical layers. Then you have the logical addresses, okay, which are nothing but internet protocol addresses. So which are four parts dotted notations मध्ये असतात. For example, if it is 123.111 dot, for example, 131.12. So this is your IP address. Okay. So this is difficult to remember. So the logical names are used. Okay. So www dot whatever dot com you write. Okay. So that is the usually address which is used. Then network architecture मध्ये Ethernet and token passing or token ring are the two types of architectures. Okay, so basically architecture मध्ये which topology you are using and how the transmission will take place, that will be decided. So Ethernet is nothing but your local area network आहे. Okay, so local area Ethernet मध्ये local area network is basically Ethernet मध्ये आहे. Okay, so 100 meters साधारण केबल तुम्ही वापरू शकता, maximum up to 10 kilometers पर्यंत. Usually earlier they were using the twisted pair cables, but usually आता coaxial cable is used. So depending upon the, you are using the thick coaxial cable or thin coaxial cable, thick net or thin net is, the Ethernet is known as the thick net or thin net. Okay, in this case, the data is sent in the small frames called small units called as the frames. Okay, they have the destination address, source address, and the message. So if the destination address is matched, then basically that particular computer will accept that particular frame and accept the message. Okay, so this is how they will transmit the data in the Ethernet. Okay, then you have the token ring or token passing. In this case, they are physically connected in the form of the star topology, but they use the ring topology in order to transmit the, or logically जेव्हा तुम्हाला data transmit करायचं, that time they use the ring topology. So in this case, the data is sent in the form of the token. If the token is empty, then the node which wants to transmit the data can use the token. And if the token is filled, then the basically the computer will check the destination address. Okay, and that destination address matches with the your node address, then it accepts that particular token. Okay, so this avoids the collision. Okay, so therefore it is nothing but also used as an access method. So access method is used for the to avoid the collision. So there are three types of access methods. One is called as the contention, token passing, and polling. So token passing is same as your token ring. आता जे आपण केलं ते, right? And then token passing and then polling. Polling is nowadays not used much. Okay. So basically token passing we had just now seen. What is it? Polling method is nothing but voting type of system. So there is a device called as controller or master device. Basically, it polls the other devices on the network to see whether they are ready to transmit or receive the data. Okay, so this is not used widely because network traffic problem hoto, therefore. So contention is the method basically in order to avoid the collision. So in this case, basically, there are two types of things. One is called as a carrier sensing or carrier detecting. To avoid the collision, carrier sensing method is used. Each computer listens if network to the network. If they want to transmit anything, they first listen. If the network is busy, then they will wait for the random amount of time. Carrier detection is similar to carrier sensing only, but computer again listens to the network if they want they transmit, right? If they detect another signal that interferes with the signal it is sending, it stops transmitting. Okay, so both the computers can wait for the longer random amount of time. That is called as the carrier detection or carrier sensing. So these are the access methods which are used. In the protocol, you have to always write what are the things which are there. There is a header part, then there is a message part, and there is a trailer part. So in the header part, there is always the source address and the destination address. The message part is actually a data. Okay, and the trailer part is mainly used for the error checking in the protocol. Protocol मध्ये जो data transmit करणार आहात, त्याचं transmission कसं पाहिजे. Okay, that is nothing but. So this is how you can just go through the networking topic. Very easy topic है.